Alright, Chapter 13, Samples and Surveys. So, this is an important topic, and it's good to understand how samples are selected, and why do we select samples, and what characteristics samples should have so that we can use them to make decisions for population. There are two surprising properties of sampling. So how is the winning car model of J.D. Power and Associates initial quality award determined? Right? So by focusing on a subset of a whole group instead of the whole group, we select a sample and use that. And by making sure that items are selected randomly from a larger group. A few definitions for this topic. When we talk about population, we're talking about the entire collection of interest, and the entire collection of interest, what we actually mean here is, let's say I'm interested to learn about behavior of students at a certain university. So all of the students who register and are students in that university are considered a population. However, we normally can't have access to everyone's opinions and everyone's information, so we collect a sample of cases that we have access to. So what is a sample? Sample is a subset of population. So when we know where our population is, then from the population we can collect a sample. And that sample is a portion of our subset of the population. And what is important for us is that the sample needs to represent population, because we're using the sample to make decisions. And as a result, if the sample does not behave the same as population, then our decision will not be accurate. How about survey? Survey is posing questions to a sample to learn about the population. So I'm sure you had the experience of having surveys. When you go to a hotel, for the hoteliers, it's important to know about your opinion. Are you satisfied with the service? What did you like and what you didn't like? And with that information, they can actually make decisions to make changes in the future. Okay, so survey is required to collect information from your population and learn about it. What's the representative? The samples that reflect the mix in the entire population are considered representative. And I told you it's important for us that a sample reflects the mix of the entire population, because we're using sample to learn about the population, and if it's a different characteristics, then it's not going to work for us. And what is a bias? Bias is a systematic error in selecting the sample. So if our sample collection has bias, then our decisions are going to be less accurate and include more errors. So what are the surprising? The surprises are the best way to get a representative sample is to pick members of a population at random. And what we mean by random is data collection is random, or sampling is random if all of those elements in the population have the same chance to be taken. We normally use a random sampling method that is structured to create a random sample for us. Larger populations do not require larger samples. So if you are, it doesn't matter, as long as you're collecting a random sample, it doesn't matter how large your sample is. Of course, depend on the analysis you are running and performing. You might need different number of samples, but that's just for the analysis. it has nothing to do with the population itself. Now let's talk a little bit about the randomization. So a randomly selected sample is representative of the whole population, and randomization ensures that on average a sample mimics the population, and that's important for us. So you can see that how important having a random sample is in decision making. So here we are comparing two random samples from a population of 3.5 million customers. You can see that average age of the population is 44.88, and the two samples that we collected, of course, they are not exactly the same as the population's average age, but you can see that they are actually close, pretty much close. How about the percentage of female? 31.51, 31.51, 31.54. They're also very close to the average of the population. Same goes with the number of children and income. You can see that they're 5 point something, 5.27, 33, 29. So these are close. And also for homeowners, 61%. All of them are 61%, and there's a change in the decimal. So this is what we want to see. We want to see that the characteristics of the groups of any specific thing that we're interested in our research. When we collect the sample, we have approximately the same characteristic, and these two samples actually create the same characteristic here. Another thing in randomization is that randomization produces samples whose averages resemble those in the population, or in other words, it avoids biases. Also, a randomization of a sample enables us to infer characteristics of the population from the sample. This example actually creates an example for us of a sampling that does not represent the population, and based on that sample, the prediction was defeat of Franklin Roosevelt in 1936. So what happened was the sample was selected from a list of telephone numbers, and since at that time telephones were luxury in 1936, and not every people had telephones. So, and another thing was that Roosevelt's supporters, they were poor people. Most of them, they did not have telephones, so they were not actually taken into account in that sample. And as a result, the decision made based or prediction made based on that sample actually was wrong. All right. Another thing that I've said that before, but it's important to remember that you might think that larger sample is better, but that is not necessarily true. So the size of the population does not really influence the sample size that we want to use. Actually, the statistical method that we're using for analysis tell us how big the sample has to be, so that that analysis and that method of statistics works for that data. For small samples, of course, population matters. One method of random sampling is simple random sample, or SRS. So a sample of n items chosen by a method that has an equal chance of picking any sample of size n from the population is called simple random sample. So normally for random samples, we need a list of our population so that we can provide a method that creates an equal chance of being picked for sample. And the SRS is the standard to which all other sampling methods are actually compared. And what is a sampling frame? A sampling frame is a list of items from which to select a random sample. So you can consider your class. I have a list of your classmates, all students in my class. And if I want to select a random sample, then it's easy for me because I have that list. So that list for me is a sampling frame. And what is systematic sampling? Systematic sampling is a method for selecting items from a sampling frame that follows a regular pattern. So this pattern can be determined by researcher based on their need, and actually depends on how many samples you want to take. If you have a class of 50 students, 50, and you need 20 samples, you can't go with the every 10 item, right? Because that just gives you maybe 5 students. So knowing how many items you want, how many samples you want is important, and then you will take the steps in a way that or pick the every nth item in a way that you can collect enough sample for your case. And if there is no fixed population of outcomes, so we don't, in a class case, we have fixed population. But if that's not the case, so no sampling frame exists. And that's the output from a production process, for example, because these outputs keep coming in and they go out, and as a result, they're not always there. The list available may differ from the list desired. So, for example, voter registration lists identify people who can vote, not those who will vote. And that's the point. You count on a person to vote, but on that day, they might or they might not vote. And that's the point. Or maybe in a medical center, not everyone who make an appointment for a medical checkup would attend at that day. Many people cancel it, right? So that's another case. Variation. So it's a topic that we started statistics with. So let's talk about variation and talk about estimating parameters first. So what is a parameter? Parameter is a characteristics of the population, like population's mean, average of a population. We show it with the mu. What is a statistic? A statistic is an observed characteristic of a sample. So the difference between parameter from now on in the book, parameter versus statistic, is parameter is a value that we calculate for the population, but statistic is what we calculate for, or estimation we calculate for the sample. And you know, for example, average of a sample, we show it with a bar. And what is estimate? Estimate is using a statistic, or in other words, using characteristics of the sample, to approximately calculate the parameter, which is the population's characteristic. So in fact, what we are doing here is we collect a sample because we don't have access to everyone in the population, and from the sample we use this sample to understand what is the average age, what is the average sales, what is the average, for example, in terms of performance of a unit, right? And we use that estimation instead of parameter, and that estimation of the parameter help us to make decisions for the population. Different things that we represent here: average, we show with the y bar for sample; for population we use mu. And standard deviation, for sample we use S, for population we use sigma, correlation we use R, for population we use rho. Slope of a line we use a B, and for population we use beta, and proportion we use P hat, and for population we use P. Now, sampling variation is the variability, the value of a statistic from sample to sample. So when you collect 10 samples from the same population, of course these 10 samples are not exactly the same, right? They don't have the same values of average and standard deviation. They're going to be a little slightly different. So that change is the sample variation, right? An example we just had the previous slides I show you here. So these are two different samples with two different values, right? So that's sample variation. So this variability in sampling or the sampling variation is actually is the price we pay for working with the sample rather than the populations. So when you keep collecting samples from your sample means, so these different samples we select from a population. For each one we can calculate an average, and these averages, they construct a normal distribution for us. So these are, majority of them are actually close to the population's average. Majority of values of smaller samples we take from the same population, they have almost a value close to the actual population, and by some of them they have more difference or higher difference from higher distance from the population's average, and that actually creates a normal distribution for us. The more samples we take, our sample means, the higher the sample means size, the better the shape of our normal distribution. So sampling variation survey results change over time. So you can see that in this case we have percentage of approval, and by time you can see that the sampling variation actually moves toward a certain point, and majority of them are going to be at certain, close to a certain value or close to an average. So this is an example in the book, Exit Survey. So please read this survey case, similar to the previous example we covered. Next topic is stratified sampling, and similar to SRS, simple random sample, stratified sampling is also a method of sampling. And we actually divide the sampling frame into homogeneous groups called strata. Let's say we have gender, we have groups of male and female, and we have a class of 100 students. But in our class we have 70% of students are female and 30% of them are male. But what we need as a sample is actually, we want equal number of male and female in our sample. As a result, what we do, so it really depends on your research, and it's very important to understand that we want to make sure that for some cases we want to make sure that the characteristic is the same. So if the sample is collected, we have 70%, 30%, but for some cases we need equal number of samples for each group. So if we want 10 from male, 10 from female students in our sample, then it's wise to separate our population into two groups, male and female, and take by random, using a simple random sample, take 10 from the male portion of the population and 10 from the female portion of the population. So use a simple random sample to select items from each strata. So first we divide our population into groups, and then we select from each group. Another sampling method is a cluster sampling, and cluster sampling is when you have normally big regions or countries or states or counties. So we divide a geographic region into clusters and randomly select clusters. So let's say we want to select a sample from the whole California, and we know that we have counties, and but we have too many counties to collect data from. So we don't want to collect data from all counties because it's time taking, because it's expensive. So we're going to create these counties, consider these counties as clusters, and randomly select some of these clusters, and then randomly choose our cases from, or samples from, these counties or clusters. So this way you're actually two times of random selection happening. One time your clusters are being sampled, and then from those sampled clusters we randomly select some items from each. Okay, then let's move on to census. So what is census? Census is a comprehensive survey of the entire population, and normally every 10 years or every 5 years the government wants to get survey and get data from the whole population and get to know how is the change in population, how is the change in gender, race, and age of people, in their income, their locations, and this way they can have better management for the country. So cost and time constraints generally prohibit carrying out a census. In some cases, a census is not really feasible because even when census happens, you can see in the US, there are many people that they're not comfortable with providing information to the government. So as a result, although we try to get more information, but many people, they do not submit their information. And although they're not many, but this way, even if 100 people don't provide the information, we don't have the whole population's info. We also have voluntary response, a sample consisting of individuals who volunteer when given the opportunity to participate in a survey. That's a voluntary response. These samples are biased toward those with a strong opinion and those who wants to actually respond. We also have convenience sampling. So it's a sampling method that selects individuals who are ready and available. Although easy to obtain, these samples are rarely representative because we did not randomly select people. Just by chance, whoever was available and ready to answer or provide our information that we are seeking, those are the ones that are answering. So that's not a good type of sample. Questions to consider. What was the sampling frame? Is a sample a sample random sample? A simple random sample? What is the rate of non-response? And how was the question worded? Did the interviewer affect the results? Does survivor bias affect the survey? These are questions we can ask about our survey and data collection, and to make sure that we have a good sample. So you can see here differences in survey results about healthcare reform in 2010 due to question wording. And Fox News, Pooh, Time Magazine, New York Times, they all had different results, and that's of course because they have different audiences, and also the way that they asked the question was different. It wasn't standardized. Okay, so best practices: randomize is very good. Plan your sampling carefully. Match the sampling frame to the target of population, and keep focused. Reduce the amount of non-response, and pre-test your survey. And pre-test means that first you create your survey, you take a small sample of 30 or 40 and test it first and see how the answers are. Do they make sense? If not, change the wording of your survey and distribute it again, and then go for a larger sample. Pitfalls: so don't conceal flaw in your sample. Do not lead with witness. Do not confuse the sample statistic for the population parameter, and do not accept results because they agree with what you expected.